After that, we are supposed to find the acceleration of point C and the angular acceleration of this connecting rod BC. So, how are we supposed to find? Now, we can use the vector equation for acceleration also. The same relative velocity equation can be used in case of acceleration. Acceleration of point C can be written as acceleration of B plus acceleration of C with respect to P. This. So I'll explain you the formula first. Acceleration of C can be written as acceleration of B plus acceleration of C with respect to B. Acceleration C with respect to B has two components, that is the tangential component plus the radial component. The tangential component is given by alpha cross R, and the radial component is given by omega square R. This is the simple equation. Like, we know that acceleration is equal to alpha R, and centripetal acceleration or centripetal or fuel acceleration can be written as omega square R. We already know, so this is just in the vector form. Here we need to take care about the direction also. Okay. Now, so let's go back to the equation. In this case, we don't know the acceleration of point B already. First, we need to determine the acceleration of point B, which also can be written as acceleration of, so here in this case, acceleration of point B can be written as acceleration of point A plus acceleration of B with respect to A in relative velocity form. There is that equation. Also, the acceleration or the relative acceleration has two components, that is the tangential component and the radial component, which I have already discussed. But since the point A is fixed, its acceleration is 0, and we have already been given the angular acceleration of this crank, that is 5 radian per second. To determine the direction, we can use the same right hand screw rule, where the thumb will be pointing in the downward direction, because this is rotating in the clockwise direction, so the thumb will be pointing in the downward direction, which is in negative k cap direction, and the position vector magnitude is 0.2 and direction is j, which you already know, plus omega square, the angular velocity is 6 radian per second, is 6 square plus into the 0.2, which is the magnitude of the crank. Now, to determine the direction of this radial component, if you stand on B and observe, if you stand on A and observe B, you need to, we know that the centripetal acceleration will always act in the, towards the center. So that is why its direction would be in this direction, which is in negative y-axis direction. So that is why I have written here negative j cap. If you evaluate this, you calculate this kj is coming out to be negative I, negative is getting positive, so it's 5, 1 and 6 square into 0.2 is coming out to be 7.2 j. So we can take this equation and plug into the acceleration equation of point C and determine the and analyze, further simplify it. So I have plugged in the acceleration of B here, and we are supposed to find this angular acceleration of B with respect to C. Has the direction k cap, since this, when this is moving downward and this is going, can be seen that this thing is overall moving in the anti-clockwise direction, so its direction is positive k cap cross the position vector of c with respect to b is 0.8, magnitude as 0.8, and it's pointing in the positive x direction, that is why it's I, minus we already know the angular velocity of this connecting rod, which is 0.8 square into 0.8. Then we can simplify this equation further, that is this is I, this is minus 7.2 j, and 0.8 alpha bc, k and I would come out to be positive j from that vector technique, and also 0.86 square into 0.8 is coming out to be 0.59 I. After that, this equation is further simplified as if you arrange this equation, then 0.59, 1 minus 0.59, both are I, it's coming out to be positive 0.41 I, and since this equation can be written as 0.8 alpha bc minus 7.2 whole bracket z. There. Now, finally, we have got this equation, and we can observe that the acceleration has two components, that is 0.41 I and 0.8 alpha bc minus 7.2 z. If you observe the diagram, then you can see that the path of this point C is in this direction and it is at an angle of 30 degrees. So if I draw that path, and if this is point C, it is pointing on this direction which is at 30 degree, then you can resolve this into two components, that is AC cos, if this is AC, then this is AC cos 30 and AC sin 30, and AC cos 30 is equivalent to 0.41 and AC sin 30 is equivalent to this. So we can write AC cos 30 degrees is equal to 0.41 and AC sin 30 degree is equal to 0.8 alpha bc minus 7.2. Now if you simplify this equation and find the value of AC, then it would come out to be 0.461 meter second minus 1. So we have found out the acceleration of point C, and if you use this and plug into this equation, then you can find out alpha BC, which is coming out to be, alpha BC is coming out to be 9.288 radian per second square. So finally we have found out the required data. This is the acceleration, and we also have found out the velocity, that is velocity of C is equal to 1.39 meter second minus 1, and omega BC is equal to, omega BC is equal to 0.869 radian per second. So these are the final data.